Good afternoon, everyone. Yes, the device is working. I hope you all had a very good lunch. It's still a few hours till the drinks, so we're going to dwell everyone more into perspectives from science. I have the honor, together with Franse Hoijmaier, to moderate this session. So we have a couple of presentations, and afterwards we have a discussion. So please collect all your questions that you have for the speakers. My name is Ellen Tromp. I work for Deltares, and I'm also coordinating with Chris Redesigning Deltas. So it's really an honor to stand in front of you. But it's really not about me. Before Chris said we're going to return to lunch, we also spoke about the exhibition. And I would like to give the floor to Tanea, who's actually done a marvelous job in organizing this conference as well. But she's going to tell us a little bit more about the exhibition. Tanea.
Thank you, Ellen. So very briefly, if you'd like to walk in the next break up the ramp, you're going to find a very tiny exhibition, which is the first part of a two-part exhibitions that we did, especially for the conference. We are having 9 international deltas in dialogue, in comparison for these 2 days. And so we took that as a chance to start diving into, let's say, into the contexts and the challenges of those 9 deltas. And we used the exhibition as a format to synthesize the learnings that we as a group, as Redesigning Deltas group, we developed so far. So what you're going to see upstairs, which is a kind of a pop-up exhibition in this room, is what we call the lexicon of the 9 deltas. So basically they are a collection of 4 different layers forming the deltas, and then a collection of objects which actually transform those deltas along the years. So ways in which these, let's say, different deltas, they have been managed, and the infrastructure and ways of living, forms of, let's say, of inhabitation that characterize them. So you're going to see them as separate elements. Tomorrow, by the end of the day, when we're going to go to the Co-Creation Center to close, let's say, the conference, then you're going to see the final part of the exhibition, which is basically let's say, the synthesis of these elements of each delta composing a story. So very in short, again, what we have initiated, let's say, the study, and what we have learned so far about them. And in addition, we have a guest exhibition developed by Sylvie Tram from EPFL, and she's doing her PhD on the Mekong Delta, so we have a dedicated room only for the Mekong Delta, and showing especially the atlases of the Dutch practices in Vietnam, specifically in the Mekong. And I guess that's it. We have also a small exhibition of our graduation studio connected to the research group, which also is going to be in the Faculty of Architecture. So you have it all in the program, and you are very welcome just to hopefully to enjoy them throughout these 2 days. Thank you.
So for now, the first speaker is Han Meijer. He is an emeritus professor in urban design at Delft University of Technology. And he is also the founding father of the research program Delta Urbanism, where it is now also the professorship of Chris. But without further ado, Han, can I invite you to take the floor?
Well, thank you very much. It's really a very big pleasure to be here, and a very big honor. And I must say I'm very impressed, Chris and Fransje and Tanea and Nikki and Ellen and all the others of the group, how you managed to bring this, let's say, Delta community together and to present, that's how I interpret it, present a program during these 2 conference days, which will be implemented, I guess, in the next years. So it's really a big effort what you did. I'm supposed to say something about Delta urbanism. What is Delta urbanism? Well, I do not pretend to give an exhaustive definition of it, but perhaps we should be a little bit careful by interpreting it as just paying attention to floating buildings or not building on the lowest parts of the land, or combining dike construction and housing. Of course, these are all elements which can be part of an integrated approach, but I think more in general, Delta urbanism is about the creating spatial conditions for organizing our society and for developing in the future our society. And in this sense, it is about land use, and by the way, not only land use, but also water use of the whole territory on the local, regional, national and international scale. How I can explain that is for me only possible by showing a project and I'm involved in, and as an illustration, as an example, what Delta urbanism can and, to my opinion, also should try to address. The project is about the new waterway, and the new waterway is an artificial new connection between the river Meuse and Rhine and the sea, created exactly 150 years ago. So this year there is also a celebration of 150 years new waterway. All kinds of events, expositions. In autumn we organize a conference on this topic, because this intervention, it seems to be a rather local intervention, but it had a huge impact on the whole region and on the whole national territory and on the whole river system, which I will show a bit later. The importance of that new waterway is also showed by this panel, which is a diorama, so a three-dimensional kind of model on a huge scale presented during the World Expo in Antwerp in 1930. So, and which shows also that obviously the state of the Netherlands and the city of Rotterdam, they wanted to show this project to the world as something which they were very proud of and which created an enormous boost of economic development and of prosperity for the city. And interesting thing is that you see the landscape here at the left is still rather empty, but new port development is already going on around the city of Rotterdam. And this was of such an enormous importance because you have to consider that the Netherlands in the 19th and early 20th century was still a rather poor country. There was a lot of richness, but concentrated in private families earned in the colonies. So, and there was an enormous poverty. The famous historian Auke van der Woud, he wrote a beautiful book on, with the title Koninkrijk vol sloppen, a kingdom full of slums. The Netherlands was the country with the most, relatively the most, the largest amount of slums in whole Europe. And Rotterdam was the king in the Netherlands. And in these 40, 50 years since the new waterway, this situation changed radically. So it was not only a showcase of, look how clever we are and how good we are in engineering works that we can make this new canal, but it was especially also, look how we succeeded to change this this very bad situation in a very in a situation of a high prosperity of the city of Rotterdam. And that the new waterway became a central element in the story about Rotterdam, you could say. The enormous amount of books, movies, pictures, photographs, paintings were published during the time to show how Rotterdam succeeded to create itself, as a matter of fact, and to create this enormous economic boost by port development and shipping. And it was not possible without an enormous transformation of the whole landscape of this previous river mouth. From a natural estuary, which tended to silt up, so Rotterdam became less and less accessible for shipping traffic, for navigation from the sea, which was really a big problem. And then this new canal turned the situation completely 180 degrees the other way around. Rotterdam exploded into the largest port of Europe, and later, even some decades, the largest port of the world. You can say the new waterway was one of the first big interventions in the Dutch water system, together with the Zuiderzee works in the northern part of the Netherlands and the Delta works after the big flood of 1953, which were the basic condition and also, you could say, a central symbol of the industrialization of the Dutch society. Building the new industrial, the modern industrial society was, as a matter of fact, boosted by these gigantic waterworks and created also a kind of national proudness, which was an important part of the public support for this new policy. And that's also, and created this situation, so the land which was still empty in the first picture is completely covered and resulted into a port, a monofunctional port area of more than 100 square kilometers from the edges of the city of Rotterdam toward the sea. And of course, it created this enormous amount of prosperity and economic growth, and resulting into the port of Rotterdam as the second largest petrochemical concentration of the world. But in the same time, you could say it resulted also more and more in the number of problems. So we cannot throw away all these elements of the 20th century, of course, but in the same time, we should be aware that the time is there to reconsider fundamentally what we did with the water system and with the new conditions in the Rotterdam region. So there is the question of the enormous concentration of fossil fuel industry, and there is more and more, as a result of this policy, also the increasing vulnerability of the urbanized area of Rotterdam itself and everything which is at the river. And that has something to do with that we should reconsider fundamentally that a territory is not something which can be built up and then it will be maintained forever as it was, but that we are dealing with a territory which is very dynamic. Not in the sense that there is sometimes less and sometimes more water, but also in the terms that it changes continuously. It is part of an evolutionary system. You could call it an evolutionary system. If you look to the territory for this time span of more than 6 or 7 or 8,000 years, then you see these pictures. But especially if you look to the course of the rivers, you see that during the last 1,000 years, the main discharge channel frequently changed from the north slowly to the south. And what happened in the 19th century is that the main discharge, which was moving toward the south from the new Meuse next to Rotterdam to the south, the construction of the new waterway was an attempt to push it back right to the site where the city of Rotterdam is situated, in order to increase the accessibility of the port of Rotterdam. And in terms of what change in the riverbed. It changed from an estuary characterized by very gradual transitions between land and water towards a shipping canal with a very sharp decision between land and water, and deepened and narrowed to create better conditions for navigation and for port activities. And to create this condition, it was necessary also to adapt the whole Dutch water system to create the guarantee that especially during droughts and dry times, during moments that the discharge is not very high, that all the water, as much as possible, will be pushed through the new waterway. So an enormous amount of civil engineering work was adapted in the Dutch river system to create this condition. And that, well, created more and more problems. First, problems concerning the whole ecosystem of the delta, which functioned, as a matter of fact, as a kind of crossroad on a worldwide scale, disappeared, especially in the surroundings of Rotterdam, almost completely. The tidal range increased substantially, with also a higher frequency of high water events in the urbanized areas of Rotterdam and adjacent towns. Salt intrusion became more and more a problem, because by deepening, the heavier salt water is able to intrude deeper into the land. And finally, you could say also the whole condition of a city at the estuary, which created the situation that in the 17th, 18th century, Rotterdam was considered as one of the most beautiful cities at the river, changed rather radically into a city high 4 or 5 meters above the river. In the last years, a lot of things changed and improved in these terms, but still there is this distance between city and water. And that's a reason why we put forward the proposal to reconsider fundamentally this whole river system, which was created from the end of the 19th and during the 20th century, and to take into serious consideration the possibility of re-shallowing the new waterway, and to create more and better conditions for not only for nature development, but also to reduce flood risk, to reduce salinity intrusion, and to improve also possibilities for spatial coherence and urban development. It links also very closely to a proposal presented by Wageningen University, which proposes, as a matter of fact, basically also this, you could say, the continuation of the tendency of the rivers, which was interrupted from the end of the 19th century until now, and of which you can say, well, this really was an interruption, and now we go on with what the river itself really wants, you could say. So from the left picture, which is the current situation, to the right picture, to use the Haringvliet Basin south of Rotterdam again as the main discharge channel, which means that a number of interventions also should take place in the river system itself, but which creates finally a situation of less vulnerability and less salt intrusion in the Rotterdam region itself. These are some projects by students of the TU Delft and the University of Applied Sciences here in Rotterdam, which so far so good underline our hypothesis that this can work very well. And it can also contribute to a more solid coherence of a green network of big green areas and zones as presented by the province of South Holland, and where the new waterway, instead of an industrial corridor, can become a central green area at the regional scale, and which also links to the existing proposals of the city of Rotterdam to change the elements of the river in a tidal park. And it creates new possibilities for new types of housing and living at the waterfront. And finally, the big thing is, of course, how do we get it organized in collaboration with the port and the port economy? Well, the point is that the port, as was mentioned several times this morning, is also facing an enormous transition, of energy transition, where 60% of the port area is covered by transshipment or storage or processing of fossil fuels. This function will change the next 10, 20, 30 years. And when you combine it with this idea of shallowing the new waterway, there are two things in one transformation. And that is, I think, the way how mitigation and adaptation should be combined, where you already can see that this is the current situation. Green is the industrial area of the port area, but in the same time you can be aware of a rising new economy in Rotterdam, and the big question is, should the economy of Rotterdam be focused only on the port, or should we have a more open eye on new economies which are rising and which can be combined with a new type of port economy in the future? So summarizing, this is the situation before the construction of the new waterway, with a shallowing river mouth new mews and the main discharge going through the Haringvliet of 80%. And then the big intervention of the new waterway changed already this discharge relation, a larger amount through the new waterway, which was especially during the industrialization period of the post-war decades, changing into that the majority of the water goes through the new waterway, and the current situation where the new waterway is the main discharge of the whole Rhine and Meuse delta, and the Haringvliet area is closed by a dam. And our proposal is to transform the new waterway itself again in an estuary, and in the same time maintaining the accessibility of the largest part of the port by the parallel canals which are already there, and with an enormous number of profits and benefits for the city and the region. So as a conclusion, I hope that this clarified something, how working with natural dynamics and having an open eye what happens with these natural dynamics on the long term, that can be an important basis for your decisions, what can become in the future, that it can create fantastic conditions for a new biodiversity, but also for economic diversity and urban diversity. And that means that we need a new story. We are still captured too much, I think, in this story about the industrial society of the post-war decades. So we have to build, and supported by our designs, on this new story on the future of the Delta. Thank you.
Thank you, Han. We're going to move to the second speaker of today, which is Marjolein Haasnoot. She's an environmental scientist specialized in water management, integrated assessment modeling, and decision-making on this deep uncertainty. She works both at Deltares and at the University of Utrecht, and she's also founder of the Dynamic Adaptive Policy Pathways approach. And I think most recently you're also one of the lead authors for the IPPC report, which was presented last year. IPPC. Hang on. On the 6th assessment report. Sorry about that. Marjolein, the floor is yours. It will turn on.
It will turn on. Is it on? Yeah, it's on. Okay. Let's the big button. Yeah. Okay. Well, thanks for the invitation and also for the nice words and also for the nice presentation on Rotterdam and shallowing. I feel a bit of a distance with the audience, so please let me know if you have any questions or if you have any doubts. Okay, so I will talk about the approach of dynamic adaptive policy pathways and include some insights from the recent IPCC report, Working Group 2 on impact and adaptation. As it's really time to move from impacts to solutions. Coastal cities, maybe I should say delta cities, they are hotspots. They are hotspots because a lot of impacts of climate change concentrate there and compound there and increase risk. They're also hotspots because a lot of people live there and there's a lot of industry, socioeconomic development. They are important for food if we look at delta scale. So they are both crucial for adaptation but also for mitigation. So this is where we can make a difference. This is one of the conclusions of the IPCC report. And these coastal areas, these deltas, they are at risk. And in this figure you see, which is also presented in the IPCC report, you see the amount of people at risk of coastal flooding of a 100-year event. And we presented it slightly different. So instead of saying in 2100 this is the risk, we looked at when can this risk occur. So what you see here is for each IPCC region, you see the amount of people at risk, and the larger the circle, the more people get at risk. On the left part of the circle, it's the absolute number. On the right part, it's the relative number. And you see where there are large circles, these are typically deltas. And what you also see, let's see if this, do I have a pointer or not? Nobody ever used a pointer? Oh yeah, oh wat leuk. No, I found something. Now yeah, you see Asia. But also, don't forget, also Europe with its deltas has a lot of people at risk. And you see with the color, this links to the timing. So the darker the color, the earlier this is. So you also see that in several deltaic regions, they are early. So in these deltas, there are a lot of challenges and a lot of climate change impacts. Increase of rainfall, we have drought, we have increase of river discharges, but also lower discharges. We have heat, we have loss of food production. So a lot of things come together in these deltas. But sea level rise is a special challenge. It's a special challenge because there are escalating impacts, they become worse over time, and there's also this possibility of a low likelihood, high and accelerated sea level rise, which has a huge impact. And third, there's also what we call a sea level rise commitment. With every degree of warming, we are committed to a certain amount of sea level rise. So in this figure, you see the amount of people at risk globally again, and you see that it's escalating. I'm showing this figure for several reasons, but one of them is that we tend to look at impacts until 2100, which has benefits because then we also see near term and long term, and 2100 is still quite far away, 80 years, so it's within the lifetime of some of our investments. But now I want to show you that if you only look at 2100, you miss this yellow part. So we look mostly at this, right? So this is important to have this, consider this long-term impacts, because maybe we will take different decisions in the near term. On the side, you see the impacts under this low likelihood sea level rise scenarios. There are two scenarios here with different assumptions, but what it shows also, these are the numbers for 2100, and you can compare them from the impact values for 2150. So the red and the blue range shows the impacts under the likely range with the IPCC scenarios until 2150. And if you compare that to the low likelihood scenarios with an accelerated sea level rise, the impacts come much earlier. But to some extent, it's a matter of time. You also see mitigation is important, right? So if we mitigate climate change, then we get into the blue futures, and if not, we get into the red futures. Time, again, is important if we think about decisions. So a lot of our typical decisions, like infrastructure, flood defenses, they take quite some time to implement them. So we have quite some lead time, which is shown in the upper part of this figure. And they also have a long lifetime. This is a picture also from the IPCC. You can see it in chapter 3, in the cross-chapter box from sea level rise. And on the top, you see the sea level rise projections. You see the likely range in the different colors. With the blue, again, is with climate mitigation, if we reach the Paris Agreement. In red, it's if we don't reach the Paris Agreement and we have high emissions. And there's this dashed lines are, again, the low likelihood sea level rise projections. So if we mitigate climate change, then the adaptation needs are much lower. If we don't, they're much higher. And if we are even less lucky, then they become much higher and much earlier also. But there's a lot of uncertainty, but there's also some certainty. And this certainty is in this long-term sea level rise commitment. And this long-term sea level rise commitment also means a long-term adaptation commitment, a need for adaptation. And this is shown here on the right. Ik ga het nog een keer proberen. So here you see until in blue, if we reach the Paris Agreement, it's up to 3 meters in 2300. In red, it's with the high emissions, and then the range goes up to 7 meters, and if with the low likelihood but high impact sea level rise scenario with a large contribution from Antarctica, we can get up to 50 meters of sea level rise. So to some extent, it's a matter of time. So what if we don't take into account this long-term adaptation commitment? We may go on a certain path and may go into a lock-in, and it may be difficult to further adapt. It's not a bad thing to not prepare. You don't have to invest already everything, but at least it needs to be considered. And as an example why time is important, here you see again the sea level rise projections and the lifetime of a measure for 50 centimeters of sea level rise. If we would have taken that in 2000, then the lifetime could have been about 110 years in a low sea level rise scenario, or it could have been about 55 years in a higher sea level rise scenario. So there's a huge difference in time. And if we would take additional measures with, again, 50 centimeters, then the lifetime of that investment becomes much smaller. And even that small, that maybe we don't have enough time to prepare and implement our follow-up measure. As this could be a pathway, right? So you implement a measure for 50 centimeters and under a high sea level rise scenario with about 1.8 meter in 2100, the lifetime is 55 years as a first step. A follow-up step of 50 centimeters would be 25 years, and then 50 years. But for preparing and implementing such measures, it can take decades. If we think about the large delta works, it has taken us about 30 years to think about it, to make a design and to implement these measures. Maybe we can do it faster, right? If you look at the Maasland barrier, the real implementation is much shorter. But we need to think about it, right? We need to rethink, redesign, think about what measures are in the solution space And how do we want to implement them? What do we need to do to keep these options open so if it happens that we can implement them in time? So in the IPCC report, we assessed a lot of literature and a lot of adaptation options. So this is a very short summary. Many of these adaptation options, they link to water and land. And this is typically, which is also can result in a competition, but potentially also synergies. So for flood risk, it's well known that early warning systems are very important and are very effective. Also flood protection, very effective. But there are also disadvantages in there will always be a residual risk because flood protection can fail. That's why we also need the early warning system. It can also have a potential lock-in. Room for the river, it has a lot of untapped potential. There has been studies that looked at, for example, at European scale, that with room for the river, a lot of flood risk could be reduced. And there's also options to avoid. We don't think about that often, but avoid is a very important strategy. Avoid building in risky places, in places that have a high risk of flooding, for example, of a high risk for drought, where it's difficult to evacuate from. And also a relocation from risky places. And to make these options have positive outcomes, we need to prepare again in advance. So for water scarcity, again, the early warning systems are very important. Water reuse, we don't do that a lot yet. Also water storage. Irrigation can be very effective, but can also result in adverse outcomes. If we irrigate a lot in one area, that also stimulates a lot of developments, and then in the end, there may not be enough water. Water reuse is very important, but if you don't have enough water, it is also difficult to reuse. And then land use changes are also a way to adapt with different crops, for example, but also in different types of building. So again, a link with redesigning. But the effectiveness of these options will decrease with increased warming. So in order to adapt, we also need to mitigate climate change. So there's also many options to adapt, and we have a lot of knowledge on that. So I think we are privileged in the Netherlands and in several other areas where we have a lot of knowledge also to adapt. But there are also limits to adaptation, also in deltas, and maybe also in our delta. Even effective adaptation cannot prevent all losses and damages. Above 1.5 degrees, some natural solutions will not work. Above 1.5 degrees, it's much, we will get less fresh water, and in some areas, the areas that are dependent on glaciers, they have not enough fresh water. But also the small islands will not have enough water. And if we in the Netherlands also, if we don't adapt, that might be a problem. Nature-based solutions, we hear about it a lot, but they require space, they require sediment, they require time to adapt. And often it needs to be in combination with engineering solutions. So we need to work together in order to adapt. Flood infrastructure cannot prevent water and salt intrusion through the ground, and needs to be combined with additional measures like early warning system. And time is needed to plan and implement. So a lot of options, they have some limits, but things can go wrong. There can be such a thing as maladaptation. We think we do the right thing, but maybe in the end we have some unintended consequences. These can be like increased risk, as you see in this example with the picture, which is a flood protection, but maybe that fails, or it protects in one area, but it makes the vulnerabilities in another area or for other people larger. And many areas are on a reinforcing pathway, which may result in a lock-in situation. For example, with increased soil subsidence or an increased risk with a high, when we have high flood defenses. This can be avoided with the systematic approach for dynamic adaptive policy pathways planning. I will not go through all the steps because of the time, but it involves mapping the solution space, think about the limits, about potential threshold, but also sequence adaptation options, and then identify near-term actions which are necessary, and actions to keep the long-term options open, identify where we need to innovate also, and in that sense also prepare and think about where are critical decisions. Because adaptation becomes more effective if we sequence all these actions, if we plan well ahead, and if we align them with socioeconomic development, and also with with different cultures and development priorities. So this is a picture also from the IPCC cross-chapter paper 2, where we have explored different adaptation pathways from going seawards, protect, but also accommodate, and also planned relocation. We did identify what could be triggers, what could be reasons to switch pathways, but also what could be potential limits of these pathways. I'm getting signals, I don't know how much time I have. Okay. Now, yeah, the challenge can become very, very large, and this is what we did for the Netherlands. We have explored what can happen, but if we break this adaptation into manageable steps, then we can identify the critical decisions. And I'll end with that. The future of our delta depends on immediate mitigation and adaptation actions. Mitigation to keep sea level rise rates below 4 millimeters a year, because that also helps ecosystems to adapt and also allows people to adapt. Adaptation is needed, but we need to avoid the maladaptation. Take into account this long-term adaptation commitment, avoid a lock-in for adaptation. And if we do that, let's take into account also other challenges like biodiversity, the housing, because if we think about it in a more integrative and multi-sectoral way, we have the opportunity to create more resilient deltas and coasts. Thanks.
Thank you very much, Marjolein. I could have listened to the complete story, but I have also time restrictions on my
I
hands.
saw it. I saw signals.
So whenever I stand up, you have 1 minute left. I don't know for you, but I could have listened to the complete story and I would just forget about the time, but unfortunately. Next speaker, he's going to bring us more information about public administration. Armin van Buren, you are a full professor of public administration at Erasmus University of Rotterdam. He's also, among other things, because the list is very long, a founder and academic director of the Erasmus Governance Design Studio. And this studio is involved in a variety of experimental design-oriented research projects and works developing on a proven design methodology for public administration. And of course you can guess why I mentioned this explicitly, because it's also very focusing on design. Not giving any much more time of you, Armin, take the floor.
Thank you also for raising the expectations quite high for this presentation. So the question for this conference is, or the theme of this conference is design for transformative change. And as a public administration scholar, I would like to put a question on the agenda: can governments design for transformative change? Is our current governance system able to accommodate design paradigms? And if yes, which ones and what changes do we need to implement in order to make our governance more ready for design for transformative change? And I would like to pay tribute to my colleague Geert Brinkman, who's not present here, but he helped me in a very significant way in preparing this presentation. I think the former speakers have said a lot about the many wicked problems we are confronted with. Problems are wicked. We are in doubt about the causes of the problems, the problem itself, the values that are at stake, but also their solutions. We disagree a lot, and it is very difficult to structure or to tame these various problems. And these problems are also intertwined. They have relations with each other. And that makes it impossible to solve them separately. I think that's also one of the messages of Han. We cannot afford ourselves the luxury of solving all these problems one by one, if it would be possible at all. And this has significant consequences for the way in which our society is governed and in which our public sector organizations are organized. To cite Henry Ford, when we keep doing what we've always done, we will always get with what we have always got. So that will not help us. And therefore, we need transformative change. And an important assumption behind this conference is that design can help us to find out how this change can look and how we can realize this. But then my question becomes relevant: can governments design for transformative change? And over the last decades, we have seen that the role of governments in realizing transformative change was often quite limited. Most of the more fundamental changes were fueled by bottom-up societal dynamics or were the result of international pressures and all that kind of things. But many of these changes were not steered from a central point of government that realized that change. Maybe the realization of the new waterway was a beautiful example of a government designing transformative change. But I'm not sure whether they foresee all consequences of their decision then. So many of these changes are not designed at all. They just happen. So then the intriguing question becomes, can governments design for transformative change? And to answer this question, we of course first have to answer the question, what is seen as design? And there are, and you know them better than I do, there are numerous definitions of design. So I normally use the definition of Herbert Simon, 1968, one of the Nobel Prize winners. To design is to devise courses of action aimed at changing existing situations into preferred ones. But I can also use the definition of Charles Eames. Design is a plan for arranging elements in such a way as to best accomplish a purpose. But more modern definitions of design are, for example, the definition of John Heskett. Design is the human nature to shape and make our environment in ways without precedent in nature to serve our needs and give meaning to our lives. And I think design scholars can make many sophisticated classifications of design orientations, but for the sake of this presentation, I want to distinguish between two families of design approaches. And the first I will call Design 1.0, design as problem solving, and the second I would like to call Design 2.0, which is design as value creation. And to my opinion, the most influential design approach in public administration is in line of the work of Herbert Simon that arises from a rational design perspective. Design as optimization, based upon a formal design methodology, based upon formal expertise, objectivity, and rationality. In that logic, design is seen as a process of search and discovery. It's about developing systematic search approaches that help to simplify and even to solve complex problems. So here we see it. Design the problem is more or less known, can be structured and can be solved. We use formal expertise based upon specialization. The line of reasoning is deductive. We have theoretical knowledge that can be used. And expertise is the main fuel of a design process. Design is a systematic search for solutions. And that can be compared to design 2.0, design as value creation, which is much more based on the assumption that problems are unknown, has to be framed before we can think about possible solutions. We need co-creation between different expertise, different fields of knowledge. It's about integrating different sources of knowledge. It's about abductive reasoning that makes a leap, a step between what a problem is and what the solution is. We need creativity, imagination, and doing justice to subjective values. So design is also a matter of empathizing with the problem, prototyping, and making the problem more complex in order to also broaden the solution space. And well, design is everywhere and everybody designs. We see a growing attention for design in public sector organizations. There we see applications of more modern types of design, service design, social design, process design. But to my opinion, traditional approaches of design dominate. Most often, design is approached as a form of rational problem solving. Also, and that I will make more explicit later on, also in the domain of delta governance. And so we try to simplify problems, we make them more abstract, design is more expert-driven, we focus on exploitation rather than exploration, and on the question how to do the things right instead of the question do we do the right things. And we can recognize this design orientation in almost all kinds of processes that are characteristic for delta management. So when we see, this is a more general picture of how fruit management planning processes are organized, strictly protocolized, within strict time constraints and predefined sectoral boundaries, focusing on well-defined problems and bounded by existing policies, norms and standards. We can also see it in asset management, well-structured linear processes, small steps in a logical sequence, which perfectly fits in our idea of task specialization and controllability. And what characterizes Dutch delta governance? I think the way in which the Netherlands organizes its delta governance is within a very strictly protocolized environment, characterized by a tight web, a dense web of institutional prescriptions. And when we look at what is design, then we see a strong focus on optimizing existing techniques and solutions. Of course, there are exceptions, like for example a program like Room for the River, or concepts like building with nature, but they have a really difficult time to get implemented. Design is meant to realize legal norms in a sober and efficient way and to accommodate legitimate objections or desires to connect other functions. The system is based upon the power of task specialization, and this is also one of its main weaknesses because it's very difficult to integrate water and environment. That always needs auxiliary arrangements like programs, like the Delta program, to organize these collaborations. And when these arrangements are removed, we see that there is insufficient capacity to facilitate this collaboration. And to my opinion, the sectoral focus is further strengthened because of a rather closed epistemic community. And as a consequence, it is quite difficult to redefine problems like a disapproved dike section and to enlarge the solution space. Although the current system is eased in a couple of directions, also as a result of the Delta program, the focus on sober and efficient solutions remains strong. And thus the focus is on simplifying problems within clearly delineated boundaries. But it is also fair to say that this system forms the foundation of a very successful policy approach. The Dutch Delta approach is internationally seen and acknowledged as a standard. And its institutional system is also seen as a hallmark for Delta management, with specialized agencies, dedicated resources, and a strong legal framework. The Dutch Delta program is seen as a successful reinvention of the traditional prevention-oriented paradigm, with more attention for risk management, more integrated planning, attention for new concepts like multi-layered safety. And at the same time, it is difficult to sustain this and to bring this from idea and concept to practice and implementation. There are some dynamics, but I think we can typify them with the term of consensual gradualism. There is some evolution in our paradigm of flood risk management, but it goes quite slowly. And the question is this enough? And is this system able to foster and to accommodate transformative change? And there, I think here we come what can be seen as, I have some doubts when it comes to this question. And that has to do with a phenomenon we know from the innovation studies. In innovation studies, there is much attention for the success trap of high-performing systems. The things you excel at get in the way of learning new things. We are very good in implementing current solutions, and that stands in the way of thinking about other solutions, thinking about redefining our problems. So the Dutch Delta governance is very good in guaranteeing our flood protection and to compensate for the consequences of all kinds of urban planning choices. And at the same time, this prevents us to think about other approaches, redefining our problems and enhancing the room for alternative solutions. And I think this also has to do with the path dependency that arises from our initial choice to opt for flood protection based upon a system of dikes, etc., and hard infrastructures. So a focus, we see a focus on optimizing current capabilities, but that also diminishes our capacity to explore new ones. And yes, of course, we see many promising examples of design 2.0. I think the whole presentation of Han fits nicely into that idea of the power of imagination, thinking about alternative futures of our current system. And we see that these projects and programs are situated quite at a distance from the current regime. So they are positioned in safe havens or pilot programs. They are sources of inspiration, and their impact is, as a result, largely conceptual. They gave inspiration, but the question is, what about their impact on policy and on institutional change? I think it is really, here we see the radicals dilemma. That kind of conceptual innovation hardly sticks. It makes maybe the mind ready for thinking about alternative futures, but their actual impact is quite small until now. And I think there's also one thing we have to discuss, Han. The question also remains, how can we combine this type of design with the questions that arise from a gamma perspective? How to combine this type of design with the questions of how to design the accompanying governance arrangements that you need to implement this. And how to proceed? My initial answer to the question. So Ellen is standing up. That's a problem. Please sit down. It does not work. Okay. Okay. I know my place. Let me say two things. How to proceed? We have to go beyond our current focus on consensual gradualism. Within our governance system, we have to think how we can build ambidexterity, how we can combine our current power in exploiting current solutions, optimizing current solutions, and how to make room for exploration, for thinking about new opportunities, for thinking about new solutions, for building new capacities. But we also have to think about how we can connect our design capacity, which is there, with questions like how to implement them, how to connect them to what we can do right now. What governance arrangements do we need? What frameworks do we need? What institutional adjustments do we need? What are the theories of change that we need to implement the attractive visions we can make when it comes to the future of our delta? So, redesigning the delta also means reimagining our governance. There is some work to do, but when we join forces, and I think this conference is a marvelous and positive signal that we can design for transformative change, and we certainly can make an impact. Thank you.
Arwin, thank you very much. Next speaker, Bas. Bas Jokman, he's a professor of hydraulic engineering at Delft University in the Netherlands. He has been involved in post-disaster research and design studies, as well in the Netherlands, but also in New Orleans, Houston, Mozambique, and various countries in Southeast Asia.
Yeah? All right. Good afternoon. I teach my students that they need to make a risk assessment as part of their civil engineering project. So before coming here, I thought, well, let's make a risk assessment of going to this place. I checked the website, Overstroming, potential flood depth of 2 meters. I checked the Dutch elevation map. We are 1 meter below sea level if we're outside, but I think at this place we're even deeper, -4, -5. And it's quite nice of you to put the speaker in the most dangerous spot. But I think no one of you is worrying at this moment about it or has worried. Thanks to the water machine, you can see even in the elevation map our dikes, our levees and the pumps. We are here in a safe place. But of course the key question is, For how long will it be like this, or how, and if and how can we adapt the system in the future to keep this level of performance and safety? If you would have followed the debate and the news over the last years, one could become pessimistic about this. Amsterdam underwater, our national philosopher, Rutger Bregman, worrying that his children could no longer live in this part of the country. Planners making designs of massive retreat. And maybe it's a bit of a coincidence that also the front page also shows this retreat strategy. So what are we up to? It's good to take a step back, and Han Meijer did that. If we talk about adapting our delta towards the long term, well, how did we get here over the course of centuries? Because that's what we're also doing, looking centuries ahead. And over time, the Dutch have changed this delta, marshy delta, into a fully controlled, almost fully controlled water machine. And it's a fascinating thought experiment. If we could step in this time machine, travel forward 300 years, what would it look like and where would we be? Which path would we have chosen, or our children and grandchildren, and so on. So it's very important indeed to explore these future paths and also to elaborate them with design, with engineering, with governance, but also with economics and social models. But let us zoom in a little bit to the past 70 years. How did we adapt our system since then? And we took with a student one section of the sea defense at Kruiningen, and this is the old cross-section just before the 1953 disaster. It was about 5 meters high with this little wall on top. And this is the sea defense as it looks now. Maybe a question to the audience, how high do you think it is now? It was 5, 6 meters? What? 8, 10? Yeah, in between, indeed. The red line, the green line shows the old cross-section, pre-1953, and the red line shows this current cross-section. It went from 5, 6 to almost 10 meters, and the footprint went from around 30 meters to 90 meters. That's, of course, a massive step. This illustrates two things. Of course, we have this enormous capability to change and upgrade our infrastructure. Yes, we can. We can have done that in 70 years. We've absorbed 5 meters of relative sea level rise. But it also illustrates the issue. The footprint has tripled. So if you are in places that are densely populated, that could lead to all kinds of issues. And an extra meter of sea level rise would add this step. So this is the next planned reinforcement. So for how long can we continue, and do we want to continue this upscaling process? We also did, as the technical experts, the expertise network on flood protection, a bit of an exploration study, still rather qualitative, but also Deltares wrote some important reports where we looked, well, given this sea level rise, so the vertical axis, sea level rise in meters, what are the possibilities if you start from the current system to upscale, and where do we find limits? The first limits we are already almost encountering for the storm surge barriers. Last week we had an interesting ice storm surge barrier conference here in Rotterdam on a very high part, on a very high hotel, so maybe there, just a suggestion, Chris. And there the first issues with closure reliability, closure frequencies already emerge. And because of those long planning horizons, we already better start thinking about those issues right now. Dikes are pretty well, if you only think about technical and economic cost issues, pretty well scalable, as just shown. And also, if you talk about the nourishments, keeping the dunes in place for the Dutch situation, that's pretty well scalable, even for a couple of meters of sea level rise. And we expect, based on the analysis that we did, that these really drastic movements, either this massive North Sea dam or the managed retreat, will be needed above those sea level rise. And just to note, this plan of the massive dams, of course, everyone thinks, oh, that's proposed by Delft engineers. No, it's proposed by our NEOS Ecological Institute by an oceanographer, because he doesn't want this plan, but it needs to be studied. And I think that's what we all need to do, study all those alternatives in an open way. Han Meijer showed the very intriguing example of a more open system in Rotterdam, and that is one of the alternatives for this intriguing system where the first issues will emerge with the barriers and the flooding of the unembanked areas. And this is just not only a technical question, like, hey, how can we upgrade the infrastructure, but of course closely connected to the issues, the ecology of the system, urban development, housing, and also the transformation of the port. And one other plan that's now also studied, also by the hogeschool students and our students, is the plan proposed by a number of retired Delta Works engineers, where they say, hey, let's build a major dam, if we need to replace that Maasland barrier in the Nieuwe Waterweg. Then we need to pump out the water from the Rhine and also make a highway, like in the plan of Han Meijer, through Haringvliet. And of course, all plans have advantages and disadvantages. This would immediately provide more protection and stable water to the city and the unembanked areas of Rotterdam. So that would mean they could develop housing in nice controlled water systems. And why is it so nice to live on your houseboat in Amsterdam? Because the water levels are fully controlled. So this plan would offer the opportunity for Rotterdam to look more like Amsterdam. I'm not sure if they like it. The farmers will like it, if they're still there, the freshwater supply. But of course, there's a hard boundary that for ecology would not be very favorable. So I think these different lines of thought need to be explored. And also an intriguing question is the shipping and the position of the port, because still now the big ships have to go quite far inland. Those questions are not only in play, so to say, here in the Netherlands, but also abroad. And many have been mentioned today. But it's good to realize that around the world, people are looking at the Netherlands, but also at their own systems to make future plans. And one of these areas where I've worked a lot, also with colleagues from the university, is this Galveston Bay area, where the city of Houston, with this massive petrochemical industrial complex, is located. And just like New Orleans, which was affected by Katrina, they are under threat of the storm surge by the hurricanes, but they are fully unprotected. So they say, hey, why can't we have a Delta Works type of system? What would it do with the Netherlands? If you turn the maps like this, you already see that this Galveston Bay is around the size of IJsselmeer, and there are all kinds of comparisons. Well, over the last decade, we've collaborated with the academic partners on further conceptualizing different solutions. Here we've shown the coastal barrier that's being, has been developed, but also in-bay solutions, nature-based solutions. Architecture students have been involved, policy students. And the interesting thing is that it kind of evolves from more an academic concept, an academic from the US who put it on the map, and it has been absorbed by the politicians and even accepted. It's now under planning, has been approved by US Congress to proceed. And these are really the mega projects. There's now a tender going out for $500 million in only the engineering cost. And this project, if built, including in-bay measures, would go over $20 billion. And of course, the challenge is not to, I've heard one famous Dutchman say, oh, they're going to build stupid infrastructure. I'm not going to mention any names. His tweet had to be withdrawn after some intervention. But also to bring in, let's say, modern ideas to do this. Okay, it is infrastructure, but in a sustainable way, minimize impact to the environment, or sometimes even improve it, include nature-based solutions. I think there's a whole opportunity for the sector, for experts to get involved there. Well, I heard someone saying it's the old technology that was built by the engineers that spoiled the delta, but luckily also the civil engineers have evolved and are evolving. What are we working on to feed these discussions and to be involved? Well, better understanding of these green and hybrid solutions, so nature-based solutions in combination with dikes, and to demonstrate how much they add to the safety and the reliability of the system, because that's what we look at in the Netherlands. Developing new materials, new types of infrastructure, like fiber-reinforced polymers are now being used in hydraulic engineering, which have all kind of advantages. And also, so I was very glad with this exhibition in the back that also showed the different types of infrastructure that you find in the Delta, but also looking at how new technologies like satellites, monitoring and so on can really assist to build a much more safer and better inspected system. But I think in engineering we're also embracing the broader concepts, because especially with the climate uncertainties, you could say the design flood is dead. We think, well, this is the 100-year flood, we design a dike, we're good to go. Well, these are two images from Limburg with a totally unexpected flooding. Very difficult to put return periods on it. That especially in these systems like the Geul River in the hill country where we can't build massive dikes, we need to think about functioning of the system, the societal system as a whole, the water system, the land use system, but also the critical functions like this is an elderly home that was flooded in the Geul. They didn't receive a warning. They called the police. They said, well, sorry, we don't have time, we can't help. They decided themselves, okay, we'll move our patients because this is totally going wrong. I think they did the right thing and prevented fatalities. So we need to think in a broader context about, okay, how can we plan and inform and involve the society to keep functioning and to enhance resilience. There, I think this multi-layer safety concept is a very good starting point, but it could, of course, also involve, so how can we combine all those aspects and also include risk information, risk awareness. And that's something that we also want to work on in this multidisciplinary setting with water and climate experts, but also people from social sciences and public health to think about issues like this. That's also something we want to do or are doing in this new initiative, the Pandemics and Disaster Preparedness Center. Also a collaboration coming from Delft, Erasmus Medical Center, also to think over pandemics and disasters, how can we prepare society in a better way? I can say it's a sister of Resilient Delta, because most of the leadership is female, so, but it was initiated by Marion Koopmans based on her experience with the pandemic, said, okay, we need to do this really in a multidisciplinary way. And maybe we can also learn from other fields. And that is shown here that both the pandemic predictions and the water level predictions in Limburg were way off. Well, what are the risk modeling concepts that help us there? How can we involve citizens and involve them when there's normal times and during a crisis and so on? So this is the agenda we want to work on with very close links to Resilient Delta. And they're intriguing crossovers. We like to plan and develop wetlands, but Marion Koopmans get a bit worried. She said, oh, could be all kind of dangerous virus outbreaks. We should look at that, we should monitor them. So that's something in our future plans, also in a changing climate, to consider. Well, that brings me to the end. Adaptation of the Delta. From a technical, I mainly talked about large-scale flooding, flood protection. I think there we can, for several meters of sea level rise, a lot is possible also with the current strategies. We seriously need to connect those disciplines and look at those various policy alternatives, because sometimes we the debate gets heated and some alternatives are left out. I think as Netherlands we can play a leading role in research and development on delta adaptation. And I think in the early plans of Rethink and Redesign the Delta, that one of the points that we want to reach was that we want to be the first with a national plan, but that sounds very singular, like a single plan, but also or multiple plans, multiple futures for our delta. There are many irons in the fire, many initiatives, but I think it's now time to join forces and well, make the next step in this larger collaborative initiative. So that's my talk, and I thank you for the invitation and your attention.
Bas, thank you very much. The next speaker is Tim Lenton from the University of Exeter. He will be joining us online. Hi, Tim.
Hi.
So Tim is the director of the Global Systems Institute and chair in climate change and earth system science at the University of Exeter. Just a small introduction, Tim. So Tim is and his group focus on understanding the earth as a system, modeling evolution, ecology and biogeochemistry, providing early warning of climate tipping points and identifying positive tipping points towards sustainability. So Tim, you have 15 minutes and the floor is virtually yours.
Thanks very much, and thanks for letting me join you virtually. Oops, I've gone too fast already. Okay. Yeah, I want to talk about tipping points. So I'm going to take a little bit of a step back, perhaps, to the global picture, both of the climate tipping point risks that we're facing, but also the fact that we're only going to avoid that through some what I call positive tipping points of transformative social change. I'm not a deltas expert, but I'll try to say some things relevant to this important topic of redesigning deltas. But let's start with a little movie of a toy model system. It's in one state, that's the ball rolling around in the valley there. It has another alternative stable state. I'm forcing the system, so I'm making the initial state less stable. And at some point, we're going to reach a tipping point where the damping feedbacks that were maintaining stability lost out, and reinforcing feedbacks that amplify change took over, and the system tipped from one state to another. Now, that kind of dynamics happens in all kinds of complex systems, obviously not all the time, but it can happen, and it's critical both for the risks we're facing to identify some key tipping points, but also I'm going to argue we need to find some, as I call them, positive tipping points to accelerate social change to mitigate the risk, shall we say, from some of the bad tipping points. So I'm going to start on the bad climate tipping points. It's a long time, nearly 15 years since I drew up a map of the bits of the Earth system, the tipping elements, we called them, that could be pushed past a tipping point this century, or in the case of the Antarctic ozone hole, that already happened. From a delta's perspective, of course, you're most concerned about ice sheets, where are their tipping points? But don't forget that if there's a tipping point in the circulation of the Atlantic Ocean, it changes the distribution of sea level height in a way that you could get up to 1 meter of sea level rise in the North Sea, in addition to whatever's happening from the ice sheets and the thermal expansion of the ocean. And if you are interested in deltas in, say, the Amazon, well, the nearby forest might be prone to dieback tipping point, or in, say, Nigeria, there's certainly evidence for potential tipping point instability in the West African monsoon. So since doing that work, we've seen, unfortunately, alarming signs of change accelerating in the wrong direction in some of these tipping elements previously identified. You'll maybe, from a delta's perspective, be most interested in the ice sheets. So we see that the mass loss of the Greenland ice sheet is accelerating. We can't rule out if it's already past a tipping point where that change becomes self-propelling, because as the altitude of the ice sheet drops, it enters warmer air that increases the surface melt and so on. But unfortunately, down in West Antarctica, there's even more compelling evidence that we might already be at or very close to a tipping point for a kind of self-propelling, irreversible retreat of part of the ice sheet that drains about 1.3 meters of sea level rise globally. But we know from our models that when you lose that part, it ultimately destabilizes the rest. And in East Antarctica, there are what are called subglacial basins, Wilkes and Aurora, each containing about 3 or 4 meters of sea level rise, also showing some worrying signs of destabilization. If you add it all up with 7 meters of sea level rise in Greenland, we could be getting close to committing to long-term sea level rise of the order of 10 meters. And the question becomes, what is long-term? But the rate at which the ice melts depends on the amount of global warming above whatever the tipping point is. So maybe taking millennia to realize those 10 meters at current temperatures, if we have passed those tipping points, but the more we warm it up, the sooner those 10 or whatever meters will arrive. So that's all part of a general message that our risk assessment of climate tipping points has been raising the red flag ever higher up the mast, if you like. So over the last 20 years, we've gone from thinking, oh, it was going to take 4 or 5 degrees of global warming before there was a serious or likely risk of tipping points in the climate system. Now, even the IPCC's recent reports would acknowledge that we're already entered the danger or risk zone at 1.1 degrees C of global warming. And 2 degrees centigrade of global warming just does not look safe at all. I mean, we could debate how safe we'll be if we can hold the line at 1.5 degrees centigrade. So it isn't published yet, but it's under review and you can find the preprint online. But we've just been updating our best assessment of where might the tipping points be for key elements in terms of global warming relative to pre-industrial. We're at the current level here. These burning embers are meant to convey the uncertainty range, the sort of range across the models and what we can deduce from the Earth's past and so on and so forth. The dotted lines are our best estimate judgments of where the tipping points might be within that burning ember range. You'll be most concerned, I suspect, about Greenland, West Antarctica, also those East Antarctic subglacial basins. But don't forget that, again, convection in the Labrador Sea, if that tips, it changes sea level height. It would raise the sea level about 30 centimeters at, say, Boston and New York. Yeah, you won't have to stare at this for too long to see that we're certainly entering the danger zone of tipping points of irreversible change in major ice sheets and possibly in aspects of the ocean circulation that matter for sea level height as well. And that was considering these as if they were independent things, but of course the climate is a beautiful coupled system, and when you tip one thing, it will affect the likelihood of tipping another. And relevant to deltas is the fact that the meltwater, that's the increasing flux of meltwater pouring off Greenland, is one of the things that's contributing to freshening the North Atlantic and weakening the great overturning circulation of the Atlantic, with its implications for sea level height, but also that in turn shifts the band of rainfall all the way around the tropics southwards, so disrupts the monsoons, for example, in West Africa and around the planet in India. Oh, and by the way, if you weaken the overturning of the Atlantic, you're basically moving less heat from the Southern Ocean to the Northern Hemisphere, leaving that heat behind. That's the big risk, really, for the Antarctic ice sheets, the warming of the ocean with its greater heat capacity than the atmosphere. So you would have got the message that I think at some point, for example, with regard to sea level rise, adaptation tipping points, as one of the previous speakers has popularized, will become inevitable. You'll have to, and many of you there, I'm sure, are working more on this than I am. But that's the perspective of someone coming from my field of understanding the global climate and how it's changing. So we will have to change strategy with regard, adaptation strategy with regard to rising sea level, and the question just becomes when to change strategy, under what scenario. But don't forget that there are other major challenges for people living in some deltas. So to To change perspective a little, well, the grey hatched area on this map, and the underlying map is global population density in a future world of 9.5 billion people, a sort of central projection. The grey hatched area is places that are under current policies, or lack of them, if you like, in a world that will therefore be about 2.7 degrees C warmer with current policies of all nations. The grey hatched areas are where unprecedented temperatures are experienced in the annual average, and that means 29 degrees centigrade and above, which today, well, historically you would only see in a few spots in the Sahara. Now, those unprecedented temperatures spread to very densely populated places, like the Niger Delta down here, like I would eyeballing it on the map, like probably where the Indus flows out, not quite on the Ganges Brahmaputra, but nearby, certainly around the Amazon Delta outflow. You know, of course, some of these are places with massive megacities. The point is, people there, if they aren't already, they'll be experiencing hot and humid extremes that are potentially threatening to life, certainly have major health consequences. So that should serve to emphasize that we've got to do everything in our power to try and limit global warming, a message that hopefully has got through to everybody. But what does that entail? It means stop going up the green line of global increase in greenhouse gas emissions and come down something like the red line. Shut down 40 billion tons of CO2 equivalent emissions per year within one generation. Oh, and then work out how to suck massive amounts of greenhouse gas out of the atmosphere for generations to come. That is a rate of social technological change that would be unprecedented. It's more than now 7% year on year reduction in emissions, at least out to 2030, by which time we need to halve greenhouse gas emissions. So my argument would be there's an only hope of achieving that kind of rate of societal change is if we could believe there were some tipping points we could trigger in society and technology that would accelerate what's called decarbonisation. Decarbonisation of the global economy needs to go about 5 times faster than it is now. But it turns out there is some evidence for positive tipping points and rapid social and technological change. Enough evidence that it's persuaded me to spend some time trying to synthesize the evidence and the theory, and with others try to develop a framework for thinking about how could we accelerate the change we need. And this framework might also be apt for thinking about the transformative adaptation challenges of deltas. As with all tipping points, the secret is to look for the reinforcing or mathematically positive feedback in a system, as well as understanding the damping negative feedbacks that maintain the status quo in the state we may start in. But that if it's your goal, or if you believe like me, we need to create transformative, rapid change, then we need to know if we've got the agency to strengthen the reinforcing feedbacks that can propel change. And then we might want to work out, well, who's got that agency, and is our agency stronger if we work together? And how close are we to the tipping points? Or in other words, how much work are we going to have to do to create the enabling conditions to tip aspects of the system? And here I'm thinking about things like fundamental shift from fossil fuel power of civilization to renewable power, electrification of transport, transformation of land and food systems, etc. Well, the evidence of actual tipping points in the last decade, they tend to come at the national scale, but they're quite striking. So here's an example from the UK. 2012, 40% of UK's electricity was generated from burning coal. Today, it's sort of 1%, and renewables have been picking up the slack. And the irreversible feedbacks that kicked in there were all triggered by a mixture of long-term investment in growth of renewables, a very modest price on carbon just in the power sector, that then meant that coal wasn't getting burned and the people invested in coal weren't making any money. The investors pulled out, the economics went bad, and then the utilities just started destroying coal-fired power stations. So we're not going back on that irreversible tipping point over on this side of the North Sea. But also in Norway, there's been a tipping point from petrol and diesel transport, or cars if you like, to electric vehicles. Again, just in the last decade, electric vehicle market share has gone from sort of almost nothing, and this is old data, now it's up above 65%, and we're seeing reinforcing self-propelling feedbacks there. We also know the more that these fundamental energy and technology changes spread, the cheaper these technologies become, and therefore the faster they spread, a classic reinforcing feedback, so that they could go global. Oh, and by the way, they feed back on each other in a good way, because renewable power is already becoming cheaper than any fossil fuel power, and it's projected to become ever cheaper still, possibly down to a fifth of the price that fossil fuels have ever been. So that further incentivizes electrifying everything else, or making clean hydrogen out of bioelectrolysis. But electrifying transport means the more you do it needing batteries in those cars and so on and so forth. The more batteries you make, the cheaper they get. Batteries are really useful if you're trying to create a renewable energy transformation, because they're one form of the cheap storage you're going to need to balance out supply and demand for renewable electricity. So I see a possibility where hopefully we're avoiding those cascading tipping points in the climate system by trying to find and trigger some cascading positive tipping points in society, technology. And I didn't quite get to talk about ecology, but my time's nearly up, so maybe we'll come back to that in the discussion. The summary is, if we go past 1.5 degrees C of global warming, we're risking multiple climate tipping points, including in major ice sheets. In my view, we're very close to committing ourselves to order of 10 meters of long-term sea level rise. But even if you don't believe that, maybe you'll believe that going to current policies to nearly 3 degrees C of warming is going to expose lots of people, hundreds of millions, including in deltas, to almost unlivable conditions. That will make some form of adaptation tipping points inevitable, but we've still got a chance to limit global warming somewhere near 1.5 degrees C. But our only chance is to talk together and work out what those positive tipping points are and how we can trigger the kind of transformative social technical change we need. Thanks very much.
Thank you, Tim, so much. And thank you all 5 speakers, I think, for very inspiring and entertaining also contributions. For the conference, we had 2 main goals. One is to really, be together as a Delta community. Also we need each other in our way forward, and this is also the question. And on the other side, also questioning the role of design in this. And I think that this session was really a nice compilation of different approaches, and especially Arwin set it all on slides, so thank you already in advance for that. And there were already 2 speakers this morning that triggered my, because I knew I had to prepare this, so that triggered my thinking on this session is that Mr. Yuk from Bangladesh, he said that design-engaged roles are various and they need to cooperate better. So this is also something I think that we've seen this afternoon, and it's also something I was questioning, especially since Peter Glas this morning also said, who is actually designing these deltas? Isn't it nature that is designing this delta? And is nature in the room? That's then the question as well. Also because I know that especially our view on what design is and what it actually can, that varies not only for ourselves, but also what you think that other designers can do. So the perception of design can be really different, and especially if you want to cooperate, you really need to bring this together. So my first question would be, and I always like to receive questions from the room, to the urban designer Han Meijer, is you've seen the presentation also by Arwin, and how do you see really the role of design for the future of the Delta? You can talk. Maybe just stand up and talk. We don't need to sit here if you want to. Yeah.
Can you hear me? No.
No.
They don't know.
Yeah.
Okay. How I see the role of design in the big tasks which have to be completed, well, is that what Arwin van Buren showed, that it's very difficult to change a situation in a given arrangement of all kinds of stakeholders, parties, etc. And we tend to think, well, let's do it, for instance, very democratic. We bring everyone who is involved or who might be involved together around the table, and we start talking what does everyone want and expect, and we hope then that we get something which can satisfy everyone. Well, the role of design, we
It's
still...
okay, you can go.
Yeah, I think it's also better.
We have instructions for the people at home who are really enjoying it, I heard. So.
The interesting thing of design that is that also on the university there's always as long as I'm on the university there is a discussion about belongs design to an academic institution like university. What has it to do with science, for instance? Well, the thing is that you can discover things by design in another way than by systematic scientific research. Design means that you, during drawing, you've come to things which you didn't expect at all. Design is not, there is also a way of design that there is a commissioner and the commissioner says, I want a house of 200 square meters and it should have 6 rooms and it should be a flat roof and please, then I know more or less what I have to do and I try to make it. But in this case, and that is the essence of what has been called research by design, is that you know there are a number of circumstances, there is a context. You should also know something about the evolution of this context, about changing character. And when you start to draw, you meet, and the first drawings are always about what is it right now? What are the things which are really important? And when I start to change, how can it be interlinked with other things? And then the funny thing is, most of the cases that you discover something which you didn't expect at all, and which can never be reached, for instance, if you start with putting all the people around the table and talk about it, when then everyone is withdrawing in its own position, and the power of design is that you can show new types of solutions which nobody thought about and which has the potential that it can satisfy everybody, or that it can play a function that people can talk about it and it can be changed by the debate with the audience, and then finally you have something where everyone, or almost, well, in many cases, someone or some parties have to take their defeat, I think, but where the community can agree with. And that is the power of design and why design should be promoted.
I see everybody nodding a lot, especially Tim is completely agreeing with you. You're not seeing this, which I'm very curious about, because in your whole story, you of course were not talking about spatial design. So if you hear Ham explain this, why are you nodding so intensely?
Because I know a little bit of the backstory of how some of these tipping points I showed you happened, and particularly in the case of Norway, that electric vehicle revolution traces back to Harald Rosvik, an architect in Stavanger, who designed a very early passive house with solar panels on the roof, batteries, and the desire to plug an electric vehicle into it for two-way sort of power storage and exchange. And he was instrumental, a designer was instrumental in having a vision of how you could have a cleaner transport system and housing and living in Norway. And he worked with, a designer may not make the change alone, but you have to have a vision And he was a smart designer who worked with a well-known friend, Morton Harkett from the pop band a-ha, who was being followed around by the media at this time in the late 1980s. And together they were able to, well, they did something practical. They imported one of the first hobby-converted electric vehicles to Norway, but they had a design set of 9 recommendations to the then Norwegian government for how to have a transformation to clean transport, low energy and efficient housing. And by bringing the media with them, because they had a pop star involved, they designed a process that ultimately led to change. So that's why I was nodding. But also because, yeah, we need to experiment, as Hannah, I think, was saying, and design and experimentation is going to give us a set of options, at least, to try to navigate into this uncertain future. And I doubt we're going to work out the best option a priori. We may have to learn by doing. That could be quite expensive, but there's a rich tradition in what's called, as you know, I think, in adaptive environmental management to sort of do some design experimentation to see how we can find a new relationship with those rising sea levels while still flourishing as humans in societies.
Clear, thank you. It's good that you mentioned the term vision, because I think that vision is also very much connected to design, because you always have, of course, an idea and an ambition. And Lodewijk van Nieuwenhuizen explained a few weeks ago that envisioning a future physically is much easier than envisioning a future socio-economically. So this is maybe for Marjolein and Arwin both. How do you see this design for the future? Because you were also questioning the design of government. Arwin, do you then mean the design of the society, or do you the capacity of governments to design as such?
Yeah, I think the latter. So I really agree with Han that the power of design in its creativity and in imagining alternative futures is really promising. But for me the problem is, what I also see when I try to do a little bit design in public administration, is that our public sector organizations are not organized to deal with this type of goal-searching, explorative processes. And you start within one corner and you end up in another corner.
Can you explain a bit better how you design then in these contexts?
So, for example, yeah, well, it's an example from a completely different field.
That's fine.
But we were asked by the city of Rotterdam to think with them about how to implement the right to cooperate, the right of social organizations, initiatives, societal initiatives to cooperate with the municipality. And they asked us to help them to develop a set of rules that they could use to implement the right to cooperate. And they're now ringing, I think. But we start with redefining the problem and redefining the idea of the right to cooperate, because it's quite strange to think about the right to cooperate, because you cooperate because you have a wish to cooperate. There is a need for cooperation. And well, we found out that it's much better to see cooperation as a learning cycle and to think about what you can bring and what you can get, and to organize the process of interaction instead of developing a set of rules. And that means the involvement of other actors, that means redesigning the rules of engagement, etc., etc. There's a long story. And we come up with a process model to accommodate the interaction between social initiatives and the city of Rotterdam. And then the process stops, because they had the idea of formulating rules to implement the right to cooperate. They stick to the idea of a right to give social initiatives the right to cooperate, and we came up with something different. That was not the responsibility of those who commissioned us. And I think that's one of the main problems when designing in public sector organizations, which are based upon the idea of task specialization, with quite strict boundaries between the various organizations of departments within such an organization. And that is simply at odds with the goal-searching, integrative, anticipatory character of design. And I think we have to take seriously the question how to enhance the integrative capacity of our governments, the anticipatory capacity of our governments, and to allow for more goal-seeking processes that allows for creativity. And yeah, then you cannot start with a clear political assignment. Then you, no, that's, so the idea of a public bureaucracy is quite at odds with the fundamental ideas of design.
So when this is a problem on already a short term, now I go to Marjolein, because you have like the long term, 2300. How do you see this tension between these sort of physical predictions that all need to somehow be, because that's also the idea, right? To feed them back into doing it differently from now on, to make sure you're not getting there or that you are getting where you want to go?
Yeah, I think with the challenges that we face, so many challenges. Some of them are on the near term, and some of them are on the long term, and some of them are very uncertain. That also means that the solutions they link to many other domains and different fields. And there, I think what I often use is then this adaptive pathways planning, is that we explore alternative sequences of different measures, that we identify what are critical decisions, what are decisions that put you on a certain pathway, what are potential lock-ins, where do we need more knowledge, and there's a link, I think, also with design and visualization, because there you can also do it together. I can show the calculations of our system analysis, but then it doesn't talk to someone else. So their design can also help, and then someone else can say, but now I miss this, or there it links like we need this other idea. So
but is design then the visualization, or is design something else as well?
No, I think both. I don't want to offend anyone with saying that design is visualization, I think different elements are needed, right? So it's both in designing things or spatial planning, but also we need the calculations. As I think there's also, it's not only design. I've been also in meetings where people draw a lot of things on maps, and we talked about things like, yeah, now we need like evidence, can things work? And there is where we can also integrate all this knowledge that there is on deltas, and think about different bits and pieces of our both near-term and long-term challenges, and then we can connect all these challenges and think what can we start with, and then on the way, find our pathway.
Can I?
Yes, I also wanted to make with Bas a bit more maybe specific for you this question, also because you showed another context. So besides sort of short and long term, also this context is for design. I would be interested if you can integrate that in your response.
Okay, sure. Now, I want to follow up on what Han and others said, that I fully agree and believe that design can lead the way in showing the possible futures. I have a feeling, and I don't want to be impolite, this is called redesign the delta, that we're talking a bit around it, but we should really start designing those potential futures and possible pathways, because now it's sometimes still at the level of very conceptual, we can do this or we can do that. The strategy you showed is already more elaborated, but if we really want to choose directions or get the discussions, we should really design them and also analyze them. Okay, where are the houses going to be? What is this going to do to nature? What is it going to cost? How are we going to govern it? So that would be it. It's also how the discussions with Annemiek Nijhoff started. Okay, we want to be this first country in the world that has a series of designs, because I don't believe it's a single design, that show how we can adapt the delta and also take on board these other strategies. So, and I sometimes have the feeling that there's hesitance somewhere in the system, that there's this, your plan, I think it should be elaborated, and the plan of Spaargaren, and then it somehow stays, okay, we do it with a number of students, and that's it, because, the Delta program or other agencies don't want to, or are a bit hesitant to really elaborate it, or don't have the funding, or that. So I think that's what we should.
I think that's a good call. And then my question,
Let's
because why are we hesitant? Because you also work with Sam in Houston. What is really the impact, also the cultural impact? Because, I mean, as the Netherlands, we have a certain approach, which is very different from the American approach. So how do you really because you showed the different interventions, you work on these projects, how impactful is the context, the cultural context maybe?
We are all, I think, in that sense, still reactive, that people only take action when they've experienced the flood. In the Netherlands, we are already partially proactive with the Delta program and the permanent funding, so that is great, but maybe we're not sufficiently proactive yet to say, okay, let's elaborate those strategies for Rotterdam and the port and the city, and whether it's closed or open.
Yeah.
I don't mind, but I think what's also difficult in it is going to bring very difficult choices. Hey, if we do this nature-based new waterway, okay, no more deep shipping. If we build the closed dam, well, hindrance for shipping and not good for nature, but very good for other aspects, you know. So there are no easy solutions, and maybe that's why people are also moving around.
Doing it differently is extremely difficult. Are there urgent questions from the room? Because Alan is already standing behind me, so I'm feeling this. No? Yes, Louisa.
Thanks a lot for this very rich panel. First question, it's about the very definition of design. I hear a bit, for my taste, a bit biased. For instance, Marjolein, so you said, design, like imagination, is good, but we need data. So my question is, the way I think we work, it is evidence-based and imagination-driven. So this is the definition of design. Do you agree? That's the question. Do you agree on the definition? Because I think...
I don't understand the question exactly.
The question is, we all talk, I mean, we listen, but about the fact that design is necessary. Design is pivotal. Then all the presentation went into what is this design, no? And while we all agree that design is necessary, there are not slightly different, but radically different visions on this, on what is the value system that characterizes this importance of designing. I'm taking the two extreme, evidence-based, imagination-driven. I speak like not as a flag of TUDF, but what we try to do, it is to combine them, what Hans said. So my question is, do you agree, as representative of the different geographies, of what is valuable in designing? Yes?
If the question is if I agree.
If you agree,
I know you do. I'm asking the others.
Marjolein, do you agree?
What?
No, yeah, you agree, Louisa says, but the question is maybe also Marjolein. Do you agree that design is evidence-based and imagination-driven?
Yeah, well, I wanted to emphasize with my comment is that we need a lot of things. So some things are design, some is imagining, some is more like evidence-based calculations, and don't hang me up on different words.
No.
So I think I agree. No. I wanted to emphasize it's more. So for me, it's about redesigning, it's about rethinking, it's about exploring different possible futures, but also thinking about so what would it mean for the systems? It's not that we can just have a linear analysis of what we have done all in the past. We need to really rethink, reanalyze all these different futures together with different disciplines and different people also.
Thank you.
But perhaps if I may add something, I think it would be a mistake to think that design can make everyone happy. And it can clarify that we have to make choices, sharp choices. And for instance, well, the example as I showed, it will have consequences for the organization of the port. And when we discussed it with the port, well, they were absolutely not amused. And how to fix that, I don't know yet. But
Someone has to take the pain, it's basically the message.
But that we also need to do it at different scales, right? You have an idea, someone else has an idea, and then we need to bring that together at this scale that you did, but also at national scale, the whole delta. Like maybe your idea can also work somewhere else, for example.
Bas is nodding. Tim is waving.
Waving.
Yes, Tim.
The conversation reminded me of the work of Joseph Tainter, an expert in the fall of past complex societies. And Joe's argument is always that we are complex societies arose because we had to solve difficult problems, originally living in challenging and marginal environments. But then complexity creates its own problems, which breeds further complexity. I'm afraid his argument is a little depressing because he suggests there's always diminishing returns on that increasing complexity, and that's ultimately the downfall of past civilizations. But perhaps design can help us here if it can at least clarify the situation. Clearly, design is about solving some very big problems that we're giving ourselves with climate change and the rest in this context. But maybe if design can actually help bring a bit of simplicity, resilience, and robustness in our response, then it might reduce the risk, if you like. Whereas if it merely keeps this like Red Queen effect of complexity begets more problems, then that's probably a worrying sign, at least in Joe Tainter's view, that we're seeing the beginning of the end, basically.
Yes, thank you so much. I need to wrap up. I think that one positive thing I heard a few weeks ago is that in complex situations, it really doesn't matter where you start the change, because any angle is basically a good start. I really want to thank all 5 speakers. Thank you very much. I want to give them a hand. Audience, thank you. Because I also really want to give us 30 minutes of enjoying downstairs a coffee or a tea, something nice, and a nice weather. Thank you.